Hello students, welcome to our next lecture on conventional manufacturing processes, and in this lecture we will discuss about different cutting tool materials. So there are varieties of different tool materials are available, and nowadays tool materials are developed. So many tool materials are available that which material to select based on our different workpieces, that is very important. And the cost of tool materials are also different based on their manufacturing methods. So in this particular lecture you will understand different cutting tool materials that are used most widely, and what are their advantages and what are the different properties. Okay, so you must need to understand different tool materials that are involved during machining processes and what are their properties also. So let us start with our first material, that is the high carbon steel. And this particular steel is mostly used in earlier times, and it is hardened and tempered for proper cutting operations. It mainly contains silicon, chromium, manganese, vanadium, and to refine its properties and grain size, the 0.6 to 1.5 percentage carbon is also added in this high carbon steel. Its hardness is approximately HRC 62. This HRC indicates the Rockwell hardness. There are three varieties of hardness testing in the Rockwell are available, that is Rockwell hardness A, B and C. And you will learn in further discussions also about these, or future semester also about these different hardness equipments. Now its hot hardness temperature is the 250 degree Celsius. Now what is this hot hardness temperature? So the ability of a material to sustain at a particular temperature without deforming its in its dimension, that particular temperature is called as the hot hardness temperature. That means if material is operated up to the, or this tool is operated up to 250 degrees Celsius, up to that temperature also, this will give a proper machining operation. So this tool will not deform. So it is called as the hot hardness temperature. In many of the cases, this tool is made by the forging process. Now the toughness of this material is very high due to the availability of the carbon content. These materials wear resistance and hot hardness is comparatively low, because as you can see this is the 250 degrees Celsius, and this value is comparatively low if we consider the materials that are available nowadays. And the cutting speed that is used for this tool is approximately in the range of 5 meter per minute. So this tool is used in earlier times, and nowadays there are many advanced tools are available that we will discuss in our further topics. Now the second tool available, that is the HSS, and it is indicated as the high speed steel. So in this high speed steel, 18% tungsten or molybdenum is available, and this is added to increase the hot hardness temperature of the tool. Now second, 4% chromium is also added, and it is added to increase the strength of the material. And 1% vanadium is available, and it increases the wear resistance of the material. So based on if the 18% tungsten is available or 18% molybdenum is available, it is added based on the requirement, because the wear resistance of this tungsten is greater than the wear resistance of the molybdenum. So based on the requirement, in this tool tungsten or molybdenum is added. Now this tool can also be hardened to various depth using proper different heat treatment processes. And what is the heat treatment and what are the different heat treatment processes, that you will understand in your further semesters. Its hardness is higher than the high carbon steel, and it is approximately near about the 67. Its hot hardness temperature is 600 degrees Celsius, and it is also manufactured using different forging processes. Now this can be used up to a higher cutting velocity or the speed, and that is approximately in the range of 40 to 50 meter per minute. Now the most commonly used tool using these high speed steel material, that are the tapes, drills, reamers, gear tools, end cutters, slitting tools, brochures, etc. This type of different tools are manufactured using this high speed steel material, and it is also nowadays used because the cost comparison with the other tools available. Now the next material available, that is the stellite, and this stellite is mainly a cobalt based alloy. So it is a cast non-ferrous alloys, and it contains 40 to 43 to 48% cobalt, 17 to 90 percentage tungsten, 30 to 35 percentage chromium, and 2 percentage carbon. And these are mostly used for the high carbon workpieces because this is mainly used. This tool involves very less percentage of carbon, so that means there are very few chances of the component to react with the workpiece that has the carbon. That means this tool is specifically developed for the machining of the high carbon workpiece component, because high carbon steel that can not be used for the component having the higher amount of carbon due to the diffusion chances. Now this tool is very hard and it is useful for the heavy cuts also. Its hot hardness temperature is approximately about the 800 degrees Celsius, and the manufacturing method of this tool, that is by using the casting process. This process you will also understand in your further semesters. And this tool is comparatively costlier than the tools that we have discussed earlier. Now the next tool, that is the carbide tool, and it is the hardest tool available from the discussed tool earlier sections. So this tool is mainly used due to its high hot hardness temperature and the higher wear resistance. Its hardness is approximately about the HRC 90, and its hot hardness temperature is about around 1000 degrees Celsius. Its manufacturing method is powder metallurgy. These carbide tools, and majorly in these carbide tools there are varieties of tools available. It may be a cemented carbide tools, tungsten carbide tools, titanium carbide tools, or maybe a tantalum carbide tools, but this cemented carbide is available in various size as inserts. They are mechanically coupled to the tool holder by clamps and braced with the tool holders. This tungsten carbide, it can work at the higher speed compared to that of the high speed steel. So it is the major advantage of using these high speed steel, using these tungsten carbide tools, because if we want to machine at a higher speed, at that time these carbide tools are helpful than the high speed steel available. And this tungsten carbide is more economical for machining of the large quantities of the parts. So its toughness is less than the high speed steel, because it involves mainly amount of material, and it is manufactured by using the powder metallurgy processes, and the components that are manufactured by the powder metallurgy process, that are comparatively brittle, and that's why their toughness is comparatively lower. Now the next tool available, that is the ceramics. So these ceramics are made of the fine grain, high purity oxides, nitrides, or carbide. So it may be a oxide, it may be in the form of the oxide, it may be in the form of the nitrides, or it may be in the form of the carbides. So most common ceramics available are the alumina, silicon carbide, and the silicon nitride. And its hardness is in the range of approximately HRC 93. Similarly, its manufacturing method is the powder metallurgy. So there are two different types of ceramics are available. It may be a white or cold pressed ceramics, or it may be a black or hot pressed ceramics. That means how they are manufactured. Based on that, these ceramics are divided. So these white or cold pressed ceramics have pressurized inserts, and they have only Al2O3 available, that is the alumina available, and it is manufactured at high temperature. Similarly, in the black or hot pressed ceramics, there is a 70% aluminum, oxygen, and 30% of titanium carbide is available. These both types of ceramic materials are suitable for continuous operations such as finishing and turning of cast iron and steel at very high speed. This means these ceramic tools can be operated at very high speed and for the finishing and cutting of the component, and it provides a better finishing than the other tools available. Now the next material available, that is the cermets. So as the name cermets indicates, we can say that it is the combination of the ceramics and the. So in the cermets, 90% ceramics are available and the 10% metal is available. These are comparatively expensive than the other earlier discussed tool. It is based on the titanium carbide and nickel binders. It has higher abrasion resistance than the tungsten carbide. That means it can resist the wear at very higher rate compared to the other tool discussed. Its manufacturing method is also powder metallurgy, and it is mainly used as the turning tool bits. During the turning operation, majorly these cermets tool are used. Its hardness is nearly about the 93. That means its HRC is 93, and For this cermet tool, the major limitation is that these fast edges are not recommended at the cermet. Means sharp edges cannot be used with the cermets because these are brittle in nature and they may get broken at the higher speed operations. Now, the next tool available is diamond, and I think we all are familiar with this tool, diamond. This diamond is comparatively harder and tougher than all the tools that we have discussed. These are the stable in nature and these are very rigid also. It provides very high resistance to the abrasion. Its hot hardness temperature is very high and it is higher than the 1500 degree Celsius. Now, if we want to use with the other material also, then we can manufacture this diamond by converting it into the powder form and by providing a suitable shape as per the required tool. And that's why the manufacturing method, that is the powder metallurgy. This diamond tool can be used at very high cutting speed, that is in the range of the 1500 to 2000 meter per minute. Now it is also used as a coating on the turning tool bits and also on many different types of the tools. And for this diamond also, sharp edges are not recommended. But the major limitation is the cost involved because the cost of the diamond tools are very high. And as the diamond involves the larger amount of the carbon, and that's why this particular diamond tool is not recommended for the ferrous materials. Because this ferrous material gets reacted with the diamond and it may deteriorate the properties of the diamond tool also. So to overcome the limitation of this diamond, other also advanced materials are developed, and one of the material, that is the cubic boron nitride. So this cubic boron nitride is consist of the atoms of nitrogen and boron, and it is developed specially with the same configuration to that of the diamond. So this particular tool is used for the high speed machining of ultra hard materials and ferrous materials. That means when the diamond tool cannot be used at that specific instances, this cubic boron nitride tool is used. That means for the machining of the ferrous materials which has the higher hardness, during these cases this cubic boron nitride is used. It has the higher hardness and higher thermal conductivity also, and it is chemically inert material. It is also used at the grinding wheel for the HSS tools and the stellites, because we know that as the machining is taking place, the sharp edges of the tools getting worn out, and to provide the further sharpness to this tool, another grinding wheel is available to provide the sharpness to these tools, and as to provide this sharpness, another tool or material is available as a grinding wheel, that is the cubic boron nitride. So this cubic boron nitride is helpful to provide the sharpness and finishing to the edges of the HSS tools and the stellites. These are available in the form of the indexable insert and are capable of machining hardened steel, chilled cast iron, higher strength alloys, and it is the hardest material next to the diamond. Its hardness is nearly about the 60 and more than that. And this cubic boron nitride is also manufactured using the powder metallurgy technique. The next material available, that is the Yukon. This Yukon, it is the nitride refractory metal and it has 50% columbium, 30% titanium and 20% tungsten with no carbide. Means in this tool no carbide elements are available. It has excellent thermal shock resistance, high hardness and the toughness. It exhibits excellent resistance to diffusion and cheap welding. It is available in the form of throwaway inserts having 3 to 5 times more edge life than the conventional carbide tools. Its operating speed is 250 to 500 meter per minute on the steels having the 200 BHN hardness, that is the Brinell hardness number. So this 200 indicates the hardness of the component, and this can be measured in the form of the Brinell hardness. And the manufacturing method of this Yukon is the wire cut EDM, because this Yukon is available in the smaller throwaway inserts, and these inserts can be manufactured only using wire cut EDM so that we can get the exact shape and size of the tool that we require. And the last tool that we will discuss, that is the Ceylon, and this term Ceylon comes from the this term is the Al, that is the aluminum. So this word Ceylon stands for the silicon nitride based materials with aluminum and oxygen addition. It is produced by powder metallurgy process, and this tool material is tougher than the alumina, and this is suited for the interrupted cuts. Mainly aerospace alloys and nickel-based gas turbine discs can be machined using these Ceylon tool bits when a cutting speed is approximately 200 to 300 meter per minute. So these Ceylon tools are used for very fine and specific cuts of the component that are used in the aerospace and the nickel-based turbine disc. So these also has the higher hardness and toughness compared to all the materials, but this particular tool is costlier than the other tools. So these are the basic cutting tool materials that are used nowadays for the machining of the different components. So based on the hardness of the workpiece, we must need to select which tool is required for our specific purpose that we need to use, because we know that if we want to cut the steel, we can use diamond also, we can use yukon also, and we can use ceramic tools also. But which tool is suitable considering the cost criteria, also considering the surface finishing requirement is also that we need to understand, and that you can select based on the properties available of the different tools. So the different properties involved for the cutting tool materials that we have discussed in this simple topic. So I hope you got the clarity about the different cutting tools available for the machining purpose. So looking forward to see you all in our next lecture. Up to then, thank you.